An amazing morning, grade 9 students. It's nice to see you again. I'm Sir Isaac De Luna, your teacher this morning. Come and join me for another fun learning experience in Science 9, only here at Valenzuela Live. We are now in quarter 2, week 7, wherein we will discuss mole concept. Let me present to you our learning competency for today. That is to use mole concept to express the mass of substances, in which we will define mole and calculate for the number of moles of given compounds. Just a few reminders before we begin. Please make sure that you have your modules and turn it on page 26 in Science section. Make sure that you also have a pen and paper with you for note-taking and problem-solving purposes. It would also be better if you have a calculator and periodic table with you. Let us begin with this game called the balancer, in which certain quantity of things will be shown at the start of each round. You have to determine which among the choices is equal to the given quantity. You can use the react buttons to choose your answer. Are you ready now? Then, let's begin. For round 1, we have here 2 pieces of socks. So, which quantity below can make the scale balance? Is it like 1 pair of socks, heart, 1 dozen of socks, or wow, 1 ream of socks? You have 5 seconds to choose your answer. Timer starts now. If you choose like 1 pair of socks, then you are definitely correct, since we know that 1 pair is equal to 2 pieces. That was a great start. Let's now continue to the next round. For round 2, we have here 24 pieces of eggs. So, which quantity below can make the scale balance? Is it like 1 gross of eggs, heart, 24 pairs of eggs, or wow, 2 dozens of eggs? You have 5 seconds to choose your answer. Timer starts now. If you choose, wow, 2 dozen of eggs, then that is awesome. We know that 1 dozen is equal to 12 pieces. And if we multiply this by 2, we will get 24 pieces. You are doing great. Let's now move on to the next round. For the last round, we have here 1,500 sheets of papers. So, which quantity below can make the scale balance? Is it like 100 dozens of papers, heart, 3 reams of papers, or wow, 500 pairs of papers? You have 5 seconds to choose your answer. Timer starts now. Amazing! You chose heart, 3 reams of papers, which is the correct answer, because we know that 1 ream is equal to 500 sheets. And if we multiply this by 3, we will get 1,500 sheets. You did great, grade 9 learners. As you have noticed, we use counting units to indicate the number or amount of things. Most counting units can only be used for physically visible objects, such as socks, eggs, and papers. Example of these counting terms are pair, which is equal to 2 pieces, dozen, which is equal to 12 pieces, and ream, which is equal to 500 sheets. But have you ever wondered how scientists count objects that cannot be physically seen, such as the particles of given solution or substance? Just like if you will be asked to determine the number of droplets of water inside this glass containing 36 grams of water. Is it possible? Well, it might be possible, but it will be real difficult to do. Particles like atoms and molecules are definitely smaller than mere droplets of water. However, did you know that determining the number of atoms and molecules of given substances is easier to do? How can it be? Well, that is thanks to Amedeo Avogadro, the one who pioneered the unit mole, which is the international standard unit for the number of particles in a substance. Particles can refer to atoms, molecules, and even ions. It is special as it can be used to count particles that are not even visible to our naked eye. But, despite being somewhat different from other counting terms, its application is still the same. Pair is equal to 2 pieces. Dozen is equal to 12 pieces. Ream is equal to 500 sheets. Mole is equal to 6.02 times 10 raised to 23rd power particles. It is just that mole contains a tremendously huge number, as it was stated as the Avogadro's number. It is approximately equal to 602 followed by 21 more zeros. In periodic table, you can see numbers below the symbols of the elements. These numbers are known as atomic mass, and these use the unit AMU or atomic mass unit. For hydrogen, its atomic mass is 1.01 AMU, and it can be simply rounded off to 1 AMU. This element's atomic mass is also numerically equivalent to what we call its molar mass, or the mass of 1 mole of this substance. And molar mass uses the unit grams per mole. So, this will give us 1 gram per mole for molar mass of hydrogen. While for oxygen, it is 15.999 AMU, and it can be rounded off to 16 AMU. And this will give us 16 grams per mole as the molar mass of oxygen. How about for water? What do you think is the molar mass of water? Water molecule is composed of 2 hydrogen atoms and 1 oxygen atom. For hydrogen, it will be 2 times 1 AMU, which is equal to 2 AMU. For oxygen, it will be 1 times 16 AMU, which is equal to 16 AMU. Adding these together will give us 18 AMU for 1 mole of H2O. And this can be converted to molar mass, equivalent to 18 grams of H2O for 1 mole of H2O. Seems easy, right? Then, how about for 2 moles of H2O? What will be the mass of 2 moles of water? We already know that 1 mole of H2O is equal to 18 grams of H2O. Now, we want to know the mass of 2 moles of H2O. Let's start with this equation. Since we want to know the mass of 2 moles of water, then our desired unit will be grams of H2O. What do you think is the correct conversion factor? We must use press like or heart button for your answer. You have 5 seconds to key in your answer. Timer starts now. Very good. Your answer is correct. We must use 18 grams of H2O over 1 mole of H2O as the conversion factor. By performing this calculation, the unit moles of H2O will be cancelled out and the unit grams of H2O will remain. And this will give us a value of 36 grams of H2O for 2 moles of H2O. Now, let's try to determine the number of molecules present in 36 grams of water. We already know that 1 mole of any substance is equivalent to 6.02 times 10 raised to 23rd power particles of that substance. So, 1 mole of water is also equivalent to 6.02 times 10 raised to 23rd power molecules of water. Now, we are trying to calculate the number of molecules present in 2 moles of water. Let's start with this equation. Since we want to know the number of molecules present in 2 moles of water, then our desired unit will be molecules of H2O. What do you think is the correct conversion factor? We must use press like or heart button for your answer. You have 5 seconds to key in your answer. Timer starts now. Excellent! Your answer is correct. We must use 6.02 times 10 raised to 23rd power molecules of H2O over 1 mole of H2O as conversion factor. By performing the calculation, the unit moles of H2O will be cancelled out. Then, we will proceed to multiplication. And this will give us a value of 1.204 times 10 raised to 24th power molecules of H2O for 2 moles of H2O. Good job, grade 9 learners. Let's sum it up. Today, we learned that Amedeo Avogadro pioneered the unit mole and mole concept. Second, mole is the SI unit for the number of particles. Third, based on Avogadro's number, 1 mole is equivalent to 6.02 times 10 raised to 23rd power number of particles that can either be atoms, molecules, or even ions. Fourth, atomic mass unit is numerically equivalent to molar mass. They just have different units. And last but not the least, molar mass of compounds is equal to the sum of molar masses of its constituent atoms. Now, let us check your understanding of the lesson. 5 questions will be shown. You have to press the corresponding reaction button for your answer. Are you ready now? Then, let's begin. Question number 1. What is the SI unit for measurement of particles in a substance? You have 5 seconds to key in your answer. Timer starts now. Time's up. The correct answer is mole. Well done, students. That was a great start. Let's now go to the next question. Question number 2. How many H2O molecules are there in 1 mole of water? You have 5 seconds to key in your answer. Timer starts now. Time's up. Very good. Your answer is correct. There are 6.02 times 10 raised to 23rd power H2O molecules in 1 mole of H2O. Let's now go to the next question. Question number 3. Which unit is used for molar mass? 5 seconds to key in your answer. Timer starts now. Time's up. The correct answer is grams per mole. Good job, students. That's already 3 in a row. Let's continue to the next question and keep the ball rolling. Question number 4. If carbon has a molar mass of 12 grams per mole and oxygen has 16 grams per mole, then what is the molar mass of carbon dioxide? You have 10 seconds to key in your answer. Timer starts now. Time's up. If your answer is, well, 44 grams per mole, then you're definitely correct. Well done, students. Now, let's take a look on how we come up with this answer. It can be calculated by following the steps we have done a while ago, just like this. Let us now go to the final question. Question number 5. How many moles of carbon dioxide are present in 132 grams of dry ice or solid carbon dioxide? You have 10 seconds to key in your answer. Timer starts now. Awesome! Your answer is correct. It is equal to 3 moles. Now, let's take a look on how we come up with this answer. The steps are also similar to what we have done before. First is to multiply the mass of the substance to the appropriate conversion factor. For this one, we will use the conversion factor 1 mole of CO2 per 44 grams of CO2. By carrying out this computation, we will get 132 grams of CO2 equal to 3 moles of CO2 as the final answer. Excellent, grade 9 students! You really have learned a lot today. That's all for today. For deeper understanding of the lesson, you will have a follow-up discussion with your subject teacher. Thank you for joining today's class. This has been Sir Isaac. See you in the next episode of Virtual Science Class, only here at Valenzuela Live, where distance is never a hindrance in learning. Stay home and stay safe. Bye!